Good morning, good afternoon, ladies and gentlemen. Welcome to another series of online lessons. If you haven't already, please click the subscribe button at the bottom there, leave a like and comment. In today's lesson, we are supposed to start looking at arithmetic series as the title. But I thought I would do maybe one example from the geometric series that we might not have grasps. So let me say geometric series example. Okay, so I think this is a very important example, and we did not do this one. I feel that we should do it before we go into arithmetic series. So maybe in the next 5 minutes, let's do this. So maybe if you are given the question, if x minus 1 comma x plus 2 comma x minus 3 are consecutive terms of a GP, which is geometric progression, or GS, which is geometric series, find x. That is question number 1. Number 2, find the 20th term. Then number 3, find the sum. What am I writing? Find the sum of the first 50 terms. Okay, so now you are asked to do this. How do you find the value of x? Well, to find the value of x, you will make use of the fact that the ratio is constant, or the ratio does not change. The common ratio does not change. So what I'm saying is that when you find the first ratio, how you find the ratio, you say the next term divided by the preceding term. So that is x plus 2 divided by the preceding term, which is x minus 1. And the other ratio will be x minus 3 divided by x plus 2, was the next term divided by the preceding term. So we use the fact that the ratio is constant, and we can equate the ratios to find the value of x. So when finding the value of x for geometric series, we use the ratios, we equate them. When we look at arithmetic progression, when finding the ratios, we'll use what we know as the common difference. We'll also be equating. So how do you find the common ratio? We found here, so we just equate them. So which is x plus 2 divided by x minus 1 should be equal to x minus 3 divided by x plus 2. So this is the common ratio. We now cross multiply. So this times that, we're going to have x minus 1 times x minus 3. This times that, we're going to have x plus 2 times x plus 2. We expand here, we're going to have x squared minus what is this, minus 3x minus x plus 3 should be equal to, expanding this, we're going to have x squared plus 4x plus 4. And working out this, we see that the x and the x there will cancel out. This will be negative 4x. So this is negative 4x. Then the other, this will come this side, so that is negative 4x, which will be equals to, when we introduce the additive inverse of 3 here, we're going to have 3 plus 4, negative 3 plus 4, of which, when we simplify, this will be negative 8x equal to negative, that would be positive 1, equals to 1, positive 1. Okay, that would be equal to 1, meaning that x will be equals to negative 1 over 8. So that is how you find the value of x. So you have done the value of x. Then from there, you find the 20th term. So I'm going to leave these two questions to you. So what you do is you have the value of x. So you say the series is x minus 1, x plus 2, and x minus 3. So is that it? X minus 1 plus 2, x minus 3. Yes. So now you put in the value of x. So that would be x, which is negative 1 over 8 minus 1 comma negative 1 over 8 plus 2 comma negative 1 over 8 minus 3. So you simplify that and you're going to have your geometric series. So simplifying this will be what? Negative 9 over 8. This will be what would this be? So when these are simplified, you're going to have that progression. So from there, you can now find the 20th term and the sum of the first 50 terms. So I'll leave these two questions for you. So you need to finish that. Then I'll just put up one more example for you. All right, so we have this x plus 5, x minus 4, x plus 3 are consecutive terms of a geometric progression or geometric series. Find the value of x, the sum of the first 100 terms, the sum to infinity, and the 70th term. So you're going to use the same procedure as we used before. So this is an activity for you. I'll be waiting for feedback. Then let me just, we're not going to do much on arithmetic series. I'm just going to introduce arithmetic series. Then we'll look at more examples in the next lesson. All right, what are arithmetic series? So as the word arithmetic, this is a series that is whose terms are found by adding. Okay, so what you should know about arithmetic series is that we're adding a certain number to, let's say this constant number, maybe we're adding 2. Let's say we're adding 2 to every number. So maybe we say 1 plus 2, the next term will be 1 plus 2, the next term will be 3. When we add plus 2 to this, the next term will be 5. When we add plus 2 to 5, the next term will be 7. Plus 2 to 7, the next term will be 9, and so on and so forth. So arithmetic series, we are simply adding a value to a number in the series, and that value that we're adding is known as the common difference. Common difference. Okay, it's known as the common difference. So basically, to find the nth term of an arithmetic series, we use the formula the first term plus the nth value minus 1 multiplied by the common difference. Okay, and how you find the common difference? You say the next term, we say term 2 minus the preceding term. So we simply subtract the next term from the preceding term. So we say term 1, right? So the next term minus the preceding term. So that is how you find the common difference. Okay, so maybe if you're asked to find T20, which is the 20th term of this series that we have here, the first term would be 1 plus n is 20, which is 20 minus 1. Then the common difference, we just say difference equals to the next term divided by the preceding term. So we say 9 minus 7, which will give us 2. So that is a common difference times 2. Then we simplify. So this would be 1 plus 20 minus 1, that would be 19 times 2. then you simplify this. So when we add everything there, we're going to have 39. So the 20th term will be 39. So that is basically how we work out arithmetic series. So this is the formula. Then for the sum, okay, for now, let's look at the first term, then we'll look at more examples, then we introduce the sum of the arithmetic series. So I'll just leave you with one task on arithmetic series, and this task will be find the 50th term of the following AP. AP simply stands for arithmetic progression. Sometimes you find AS, which is just arithmetic series. So find the 50th term of the following AP. So the series is, okay, so this is the sequence 2, 4, 6, 8, and so on and so forth. So you're going to find the 50th term of this sequence. Then from there, we are going to build on. So have a good evening.